Welcome back. This is Miss Rubright, Advanced Geometry 7-3. Use similar right triangles. I know you guys want me to do a little sign-on, so this is Miss Rubright. 7.3, use similar right triangles. Identify the similar triangles in the diagram. All right, guys, so these are a little bit annoying. You actually have to draw all three of these triangles separately. So when I talk about all three of these triangles, we're referring to this smaller triangle, like this medium-sized triangle here, the small triangle over here, and then the third triangle would be the entire large triangle. So we have a small, a medium, and a large. And we're separating this into three separate pictures. So to draw these things, we should add in, because this is a linear pair, this is where the right angle goes. So we have our right angle on the smallest one here at U. Our short leg is to the S, and then our longer leg to the T. So then when we use our middle length one, once again, U is our right angle, so we make sure that it is. The short leg is to T, so the T goes here, making the R there. And then on our whole shape, the 90-degree angle is at the right angle is at T, and our shorter leg is the S, making the R there. Once you have them drawn in corresponding positions, you can write their similarity statement. So triangle STU is similar to triangle TRU, which is similar to triangle SRT. So you can actually write out a similarity statement once you have that. They went with TSU, RTU, RST, just as long as you do it in the same order on all three. It doesn't matter where you start, just as long as you continue the pattern. The diagram below shows a cross-section of a swimming pool. What is the maximum depth of the pool? All right, so we were looking for this height here, and then we're going to add it to this height to find the maximum depth. So in order to find this height, we can use this is a right triangle and this is a right angle. So there's a couple different things we can do. We could draw these out separately to be able to do our proportions, or we could do I would do this. All right, this is the easiest way. The whole hypotenuse, remember how I taught you guys this before, earlier today? The whole hypotenuse is to the leg, as the leg is to the portion of the hypotenuse closest to it. The whole hypotenuse is to the leg, as the leg is to the part of the hypotenuse closest to it. So 165 is to the leg, 64, as the leg is to the part of the hypotenuse closest to it. So cross products and solve. 64 times 64 divided by 165. I got 24.8. So if this is 24.8, and I'm leaving the entire unrounded answer in my calculator, and I'm looking for this h, it's going to be this squared, right? And I'm subtracting that from this squared because it's going to be h squared plus 24.8 squared equals 64 squared. I can use my memory buttons in my calculator, so I'm going to store 1. So I have my h squared plus my recall 1 squared, right? It's a memory 1, equals 64 squared. So essentially I'm just going to 64 squared minus recall 1 squared equals, and then I have to take the square root to solve for h, and I got 58.98, which rounds to 59 inches. Your height is 59 inches. So if we have 59 inches plus 48 inches, what is my maximum? 106.98, or 107 inches deep is the total depth. They drew them out separate to do the proportions. That way is fine too, but I like the shortcut because then you don't have to draw them all out. So they got the 59, and then they added it to the 48, and they got the 107 that we got. But we didn't have to draw it all out. All right, so identify the similar triangles. So you would have to draw it out to identify the similar triangles. That part kind of is annoying. So if we drew the small one, the medium one, and the large. On our small one, we have the right angle at H. We have our shorter leg to E. So we can put it up here. And our longer one is a G. On here, the medium size, our right angle is on H. Our shorter side is the G, making this F. And then on our large one, we have G as our right angle, shorter side E, larger leg F. Make sense? That's how we can do our similarity statement. Then find the value of X. Well, GH is X, GH. GF is 4. And GE is 3. All right, so if we're finding X, we could use, if this is a 3 and a 4, what is this? A 5. So we can say 5 is to 4 as 3 is to X. Cross products and solve. 5x equals 12. So 12 divided by 5 is going to be our answer. 2.4. Another way we could do this is the way that I was showing you earlier. The whole hypotenuse is to the leg, as the leg is to the portion of the hypotenuse closest to it. 5y equals 16. So y is 16 over 5. So if we had 16 over 5 here and use Pythagorean theorem, we would have 4 squared, or 16, minus, in parentheses, 16 divided by 5 squared equals, and then square root, and we get 2.4 as well. So we get the same answer for x of 2.4 using the whole hypotenuse is to the leg, as the leg is the part of the hypotenuse closest to it, and then using this number in a quick little Pythagorean theorem. All right, so on our next one, we can draw out the 3 shapes separately. So we have our small one, our medium, and our large. We have our right angles. All right, so on the small one, the short leg is the L, the right angle is the K, making this M. On our medium-sized triangle, we have the K as our 90 degrees. The short leg goes to the M, so this is J. And then on our large one, we have the M. Short leg is L, and J goes there. And we can fill in all of our information. LM is 5. KM is X. And JM is 12. So looking at this information, if we're trying to solve for x, we could use We'd have to solve one of the triangles to be able to know. 5, 12, and what? Isn't that a Pythagorean triple? 5, 12, 13 is a Pythagorean triple. If you didn't realize that, 5 squared is 25, 12 squared is 144. When you add them together, you get 169. The square root of 169 is 13. Once you add in this 13, your 13 is to your 12, as 5 is to the x, right? 13 is to 12, as 5 is to x. Cross products and solve. 12 times 5 is 60, divided by 13 is 4.61. 60 over 13, or 4.61, is our x. We okay? Use the geometric mean. So these are the shortcuts. These are the ways that I like to do it. Find the value of y. The whole hypotenuse is to the leg, as the leg is the part of the hypotenuse closest to it. The whole hypotenuse is to the leg, as the leg is to the portion of the hypotenuse closest to it. Y squared equals 9 times 3, 27. Square root, 9 times 3, so it's going to be 3 rad 3. Y is 3 rad 3. We okay? Rock climbing wall. To find the cost of installing a rock wall in your class gymnasium, you need to find the height of the gym wall. You use a cardboard square to line up to the top and bottom of the gym wall. Your friend measures the vertical distance from the ground to your eye and the distance from you to the gym wall. Approximate the height of the wall. All right, so we need to know how tall this is because we don't have a way of measuring that high. They don't have a long enough measuring tape or the ability to get it to go all the way up there, so they're using the geometric mean instead. So how are we going to do this? There is another pattern. The part of the hypotenuse is to the height, and this only works if it's two right triangles, right? A right triangle with a height. The part of the hypotenuse is to the height, as the height is to the other part of the hypotenuse. This is to this, as this is to this. 5 is to 8.5, as 8.5 is to what? Cross products and solve. 8.5 times 8.5, or 8.5 squared, divided by 5 equals, cross products and solve, 14.45. W is 14.45. And they want to know the total height of the wall. So the 14.45 plus 5 is going to give you a total of 19.5. Make sense? Are we okay on that, guys? Yeah? Right, moving on. That was everything in this lesson. So I hope you enjoyed our lesson on 7.3, use similar right triangles. See you next time.